give me one, give me one, give me one, give me one.
Hi everyone, this is Naveena from the Department of Cyber Security in the Institute of Aeronautical and Engineering, Dundigal. So today my topic is computer networks. In this video, and I want to discuss about the TCP IP protocol suite and the transmission media under the networks. So at the final of this video, the students can able to learn understanding the concept of TCP IP protocol suite and the functioning of its layers, transmission media and its types and its networking schedules. So the outline of the today's video is network model, TCP IP protocol suite, transmission media. So coming to that, the first topic of our today's discussion, it is nothing but the TCP IP protocol suite. The TCP IP protocol suite consisting of mainly the 5 types of layers and which will be mentioned in the given diagram. The first layer is nothing but the application layer. The second one is the transport layer. Third one is the network layer. The fourth one is the data link layer. Fifth one is the physical layer. So let us see one by one what are the layers present under the TCP IP protocol suite and what are its functions and how far they should be related with the networks. So coming to the layered architecture of a TCP IP protocol suite, to show how the layers in TCP IP protocol suite are involved in communication between the two hosts. That means the one host is a source host, second host is a destination host. If you can assume that we want to use this suite in a small internet made up of 3 types of LANs, that each LAN which should be linked with a link layer switch. We also assume that the links are connected by one router as shown in the below figure. So coming to the given example, if you can see, these are the type of layers which will be situated and connected by means of a one router. So if you can identify each and every layer here, they should be having one source node as well as the destination node. The application must be having the source and destination host, and transport layer is also having, and network layer is also having, data link layer is also having, and physical layer is also having the 2 type of hosts which should be mentioned like the source host and the destination host. So coming to the communication sake, if you can mention in the below example, so the source host A, the link layer, the first link layer will be switched with the source host A and the second link layer will be switched out to the destination host B. So both these 2 link layers will be associated or attached with a one router which will be situated at the center of between the 2 link layers, and below the third link layer will also be attached to the root. So here one router will be there. What do you mean by a router? A router is nothing but a device which can able to connect between the 2 switch type of networks or 2 subnets. So here a router can able to connect between the link 1 layer of a source host, link 2 layer of a destination host B and the link 3 layer of a destination host C, which all these the 3 link layers can able to attach by means of a one router named as the central located router. So coming to the next points of it, the key points of a layered architecture, let us assume that computer A communicates with computer B as the figure shows. We have 5 communicating devices in this communication as I have already discussed with you. Always here, what are the functions? It will be involved by means of a source host and the destination host. Means the source host needs to create a message in the application layer and send those messages to its below layers, down of the layer, so that it will be physically sent to the destination host. What is the task performed by the destination host? Means the destination host finally needs to receive the communication at the physical layer and then deliver it through the other layers from the application layer. So coming to the logical connections which should be situated under the model of a TCP IP protocol suite, for the better understanding of each the tasks or the duties of each layer, we need to think about the logical communication which would be applicable each and every layer which are situated under the protocol suite. So the below figure shows how the logical connections will be implemented in our simple internet. So we can have a need to define here the application layer having one source host and the destination host. Here the transport layer, if you can see, as the figure shows, the duty of the application transport and the network layers is end to end. So the application layer is also having the two types of host. The first one is the source host and the destination host. Application layer and the transport layer is also having the end-to-end type of network communication or the message passing we have to see under the application layer and the transport layer. So coming the duties of the data link and the physical layer is hope to hope, in which the hope is if you can define, the hope is a host or a router. So in other words, the domain of a duty of a top three layers is the internet, and the domain of the duty of the two lower layers is nothing but the link. So in the top three layers, we have to define one by one. In the top three layers, the network layer, the message passing, the means of communication is by means of a data packets from one source host to the destination host. Whereas coming to the data link layer, the message passing or the communication we have to see by means of a data frames, splitted in the form of a data frames from a source host to the destination host. Coming to the physical layer, the data packets can able to split it in the form of a bits from one source host to the destination host. So here again we have to identify the source and the destination host will be linked. One source host will be there. Suppose if you can define it, assume it or by means of a and the destination is the B. So here one router will be there which will be centrally located, and one link layer already I have explained, the LAN 1. This is the LAN 2, which should be linked and associated by means of a centrally located router of source A host and destination host B. So coming to the under the third element or the third function of a TCP IP protocol suite, here we have to identify the objects or the messages or what we can call the data packets which are meant for the sake of a message communication under the computer networks, identical objects in the TCP IP protocol suite. So in the application layer, according to our discussion, so the application layer simply the messages will be sent from one source host to the destination host. Coming to the transport layer, the identical objects or the messages or the segments in the form of a user datagram from one source to the one destination. Here the transport layer always meant for to providing the services to the below layers. So coming to the third network layer under the TCP IP protocol suite is the network layer, and which is having the type of message passing which we meant by means of a datagram communication only from one source to the destination. If you can define what do you mean by datagram, a datagram is nothing but a unit of data, a unit of a packet which is meant for the sake of communication only. And second one, so coming to the last but the least layer of this TCP IP protocol suite is nothing but the data link layer, and which you can identify the passes of the message or the means of transportation of a message passing is by means of a frame. Here the data packets which will be splitted in the form of a frames, they can able to transmit from one source host to the destination host. So coming to the last layer of our TCP IP protocol suite is nothing but the physical layer, which the means of transport or the message can able to split in the data packets or can able to split in the form of a bits which can able to transmit from one source host to the destination host. These are the identical objects what we can call the types of data packets which can able to transmit from one layer to the another layer in the TCP IP protocol suite. So coming to the description of each layer or what we can call the application layer and its functions, the logical connection between the two application layers, that means from one source host to the destination source is end to end. The two application layer exchanges easily messages between each other or transmit the communication media between each other from one source to the another source. So, however, communication at the application layer is between the two processes. To communicate one process or one application, a process sends a request to other processes and receives a response. Process to process communication is mainly the duty or the task assigned by the application layer. So coming to the next layer which should be meant under the TCP IP protocol suite is nothing but the transport layer. The logical connection at the transport layer is also end to end. The transport layer at the source host gets the message from the application layer. So it encapsulates the transport layer in the form of a packet, what we can call it as a segment or user datagram, and sends the data by means of a UDP protocol, user datagram protocol. So the transport layer, mainly the task or the vital role played by the transport layer is nothing but responsible for giving services to the application layer to get a message from application program running on the source host and deliver it to the corresponding application program on the destination host. So here the TCP provides flow control matching the sending data rate of the source host with the receiving data rate of the destination host. Here the source route is always parallelly or equalized to the destination source route. So error controlling guarantees that the segments arrive at the destination without the error and resending the corrupted ones. And we have to identify the congestion control under the TCP IP protocol suite. Congestion control is meant for, or we can define what do you mean by congestion control is to reduce the loss of segments while transmission from one source to the destination source. So here if you can define or if you can discuss means there are a few transport protocol layers in the internet. Each is designed specifically for some specified tasks. The main protocols here means the TCP IP, Transmission Control Protocol, and the Internet Protocol. So the TCP IP protocol here, it can create a logical pipe between the two TCPs for transferring a stream of bytes under the networks. So coming to that, the network layer and its functions under the TCP IP protocol suite, the network layer is responsible for creating a connection between the source computer and the destination computer. The communication at the network layer is host to host. So the network layer is responsible for the host to host type of communication and routing the packets through possible routes. Here if you can identify whatever the data packets they need to communicate from one source host to the destination host under the layer of a network layer, they should have some internet identification address that should be performed by means of a internet protocol. So IP also defines the format and the structure of addresses used in this layer. An internet protocol is also responsible for routing of a packet from its source to its destination, which is achieved by each router forwarding the datagram to the next router in this path. So coming to that, the data link layer under this TCP IP protocol suite, it is mainly responsible for taking the datagram and moving it across the link. The link can be wired within a link layer switch and a wireless LAN or either by means of a wired WAN or a wireless WAN. So the data link layer are the main task performed by the data link layer means it takes the datagram and encapsulates it by means of a packet mode called as a frame. And each link protocol may provide a different service. Some link layer protocols provide complete error detection and correction methods. So coming to the last layer of a TCP IP protocol suite, the physical layer is responsible for carrying the individual bits in a frame across the link. The two devices which are connected by transmission media, the first one is the guided and second one is the unguided. The guided media is meant for the cables or wires and the unguided is meant for the wireless communication. Here we can discuss about the transmission media. It does not carry any bits. It carries by means of a electrical or optical signals. So the bits received in a frame from the data link layer are transformed and sent through the transmission media. But we can think that the logical unit between the two physical layers in two devices is a form of a bit. There are several protocols that transfers a bit into a signal. So here the next main element of a TCP IP protocol suite is nothing but the encapsulation and decapsulation. So one of the important concept in protocol layering is nothing but the encapsulation and decapsulation. The process of adding and removing of the control information of messages throughout the layered architecture, what we can call that process, what we can call it as encapsulation and decapsulation. Here this is one of the example throughout all the layers which will be connected under the TCP IP protocol suite. Here the application layer simply consisting of one message at the source and one message reached successively by means of a destination. And here coming to the transport layer, the four messages, they will be coming into the transport layer by means of a through router. It will be reached successively to the destination end. So coming to that, if you can discuss by means of a network layer, 3-4 bits they were coming and they will have some communication media. They will transmit through by means of a one communication and it will reach us the destination in the form of a 3-4 bits. So coming to the data link layer here, the 2, 3, 4 bits will be added and they will transmit and reach to the successfully destination by means of in the mode of a 2, 3, 4 messages. So in the physical layer, which is especially meant by means of a transmission media, the transmission media which should be present under the physical media by means of either cable or air or a wireless technologies. So coming to that, the encapsulation and the source host. At the source we have only encapsulation and in the application layer the data to be exchanged is referred by means of a simply message or a data packet. A message normally does not contain any header or trailer when we have discussed about the application layer. We have to see in simply an application layer consisting of only message. It does not contain any header or trailer. But if it is having or if it does means we refer to the whole as a message. The message is passed to the transport layer. It takes the message as a payload. The load that the transport layer should take care of it, it adds the transport layer header to the payload which can identify the source and the destination application programs which communicates plus some more information that is needed from end-to-end delivery of the message, such as information needed for flow, error control or congestion control. And here, if you can finally see the result of a transport layer packet which is called the segment in TCP and the user datagram in UDP, the transport layer then passes the packet to the network layer. So coming to the third point under the encapsulation decapsulation, the network layer takes the transport layer packet as data or payload and adds its own header to the payload. The header contains the addresses of the source and destination host and some more information used for error checking of the header, fragmentation information and so on. The result is the network layer packet, what we can call it as a datagram. The network layer then passes the packet to the data link layer. Here the fourth point is nothing but the data link layer takes the network layer packet as a data or a payload and add its own header which contains the link layer addresses of the host or the next hop, the router. The result is the link layer packet which we can call it as a frame. The frame is passed to the physical layer for its transmission to the destination host. So coming to the decapsulation and encapsulation at the router. At the router we have both the decapsulation and encapsulation because the router is connected to both the source as well as to the destination host. So as I have already defined, a router is nothing but a device which can able to connect the two type of devices like the switch networks or subtype of networks. So after the set of bits are delivered to the data link layer, this layer decapsulates the datagram from the frame and passes it to the network layer. The network layer only inspects the source and destination addresses in the datagram header and consults its forwarding table to find the next hop to which the datagram is to be delivered. And the third point, if you can define under the decapsulation at the router side, the data link layer of the next link encapsulates the datagram in a frame and passes it to the physical layer for the transmission of media from one source to the destination source. And coming to that, the last point under the decapsulation at the destination host, and each layer only decapsulates at the destination host by means of a packet received removes the payload and delivers that payload to the next higher level of protocol until the message reaches to the application layer. It is necessary to say that decapsulation in the host involves error checking. So up to that we have already discussed that I discussed related to the TCP and IP protocols soon. Now I want to discuss the second section of a transmission media under the networks. So if you can define the transmission media, what do you mean by a transmission media? What are the type of transmission media and how far they should be useful to the society, and what are the types of transmission media vigorously using nowadays by means of a society and the people. Let us discuss one by one. The transmission media are actually located below the physical layer of TCP IP protocol and consisting of the two types of transmission. We could say the transmission media belongs to the layer 0. Below figure shows the position of transmission media in relations to the physical layer. In telecommunications, the transmission media can be divided into two broad categories. The first one is the guided one. Second one is the unguided one. Guided media include twisted pair cable, coaxial cable and fiber optic cables. Unguided media is purely meant for wireless communication or for free space communication only. So this is one of the simple example which I want to discuss, like the one sender and the receiver will be there and the transmission media either it should be by means of a guided media or unguided media. So here I want to discuss about the pictorial representation or schematic diagram of a one transmission media. The classification of a transmission media, if you can see, the transmission media consisting of the two types of media. The first one is the guided, which we can discuss in second way, or we can define in a second way means wide. The second one is the unguided, what we can define in a second way means wireless. So under the guided wide communication, these are the examples for the guided media: twisted pair cable, coaxial cable, fiber optic cable. And coming to the unguided, radio wave, microwave and infrared. So coming to that, the first section of a transmission media or first division of first part of a transmission media I want to discuss, that is nothing but the guided media, which are those that provides a conduct from one device to the another device. Include twisted pair cable, coaxial cable and fiber optic cable. A signal traveling along any of these media is directed and contained by means of physical limits of the media. The twisted pair and coaxial cable uses the metallic type of copper materials which can be act as a conductors as well as the insulators. The conductors that accepts and transports signals in the form of electrical currents. The optical fiber is a cable which accepts and transports signals in the form of a light. So coming to the guided media, and the first one is the twisted pair cable. A twisted pair consisting of the two types of conductors which will be made by a material normally called it as a copper wire, and each with its own plastic insulation twisted together according to our given below diagram, as shown in the given diagram. The first part is we have to identify here the two types of cables. They are paired together or twisted together. These two type of cables are made up of by means of a copper wires, and the one side it will be collectively called as an insulator. The second side is a conductor, which are separately attached or separately connected, and one is meant for the insulator and second is worked as a conductor. And the second one is the twisted pair cable. In this one, the unshielded and the shielded twisted pair cables we have to identify. Two type of twisted pair cables are there. The first one is the UTP and second one is the STP. And UTP is meant for unshielded twisted pair cable. STP is meant for shielded twisted pair cable. So what makes the difference between these two type of twisted pair cables are, so if you have identified the diagram of these two sections, the UTP means here it will be also paired like the twisted pair only, it can be attached. The two types of pairs it should be attached, and here situated or located or attached to the plastic cover under the two types of wires. So here if you can identify, the plastic cover will be there for the sake of the two type of twisted pair of cables, and again it will be shielded by means of a metal shield. So although the metal casing improves the quality here, the quality of the cable by preventing the prevention of noise or any breaks or any crosstalks, for the sake only, the UTP should be replaced by means of a STP. The STP is, now they are using the STP, that means shielded twisted pair cable, which is more flexible and vigorously using by the society today. So our discussion focuses primarily on UTP because STP is seldom used outside of the IBM. So coming to the categories of the twisted pair cable, according to the EIA, Electronic Industries Association has developed the standards to classify unshielded twisted pair cable into 7 categories. Those categories are determined by cable quality, with 1 as the lowest and 7 as the highest. Each EIA category is suitable for specific uses under the table 6.1 shows these categories. If you can define the category 1, the bandwidth is less than 1 and the maximum data rate is less than 100 kbps, the application is used for the telephone lines. If you can take the category 2 and its bandwidth is 4 and the maximum data rate is 4 Mbps and the application is meant for IBM token ring LANs. So coming to the category 3 and the bandwidth is 16 and the maximum data rate is 16 Mbps, 3 to 4 twist or foot 10-base-T LANs currently used in telephone lines. So coming to that, if you can take the category 4, 20 and the maximum data rate is 20 Mbps and the application type is 16 Mbps token ring LANs. So coming to that category 5, the bandwidth is 100, the 100 Mbps, the 1000 Mbps, the 4 pairs of twisted cables we have to identify seen here, and 100 base T fast Ethernet and 155 Mbps ATM network and gigabyte Ethernet we have to see here. Coming to that category 5E, the bandwidth is 100 and the 100 Mbps, 1000 Mbps, 4 pairs of cables are used here, the maximum data rate increases. So here the application type is 100 based twisted pair, fast Ethernet and 155 Mbps, the ATM network and gigabyte Ethernet. So coming to the category 6, which will be the bandwidth is 200 to 250 and the maximum data rate is applicable 1 Gbps and the application type is gigabit Ethernet. Coming to the category 7 and the bandwidth is 600 and maximum data rate is 1 Gbps and the application type is gigabit Ethernet or long distance, then category C if you are comparatively users. These are the type of categories of UTP cables which are associated under the EIA, Electronic Industries Association. So coming to the connectors, the type of connectors and how many types of connectors which are using under the twisted pair cable. The most common UTP connector is RJ45 and RJ stands for the resistor jack. As shown in the given figure 6.6, the RJ45 is a keyed connector, meaning the connector can be inserted in only one direction or in a single way of direction. So let us discuss the applications of its twisted pair cable. Twisted pair cables are used in telephone lines to provide voice and data channels. Local area networks such as 10-base-T and 100-base-T are used like in the means of a twisted wire cables. So coming to the next transmission media under the guided media are nothing but the coaxial cable, and it consisting of the two type of conductors shares the same axis, hence call it as a coaxial. So here if you can see the diagram of a 6.7, in the center of this coaxial cable, center of the cable surrounded by means of insulator and which will be shielded by means of a PVC, polyvinyl chloride, surrounded by the second conductor, which we can call it as outer conductor, protected by means of a shield, which is again further surrounded by means of a insulator, again the upper level, and thick plastic jacket forms that covers of the cable as shown in the figure. So here it will be protected and shielded and encases by means of an inner conductor, insulator outer conductor, that what we can call it as a shield, and the plastic cover. So if you can define, the coaxial cables are classified according by their radio government ratings, like the twisted pair cables, and cables resistance to DC, direct current, and AC, alternating current, measured in the mode of a ohms. So coming to the category, impedance and application, RG8 and RG11, 50 ohms, and the application type is 10 base 5 thick Ethernet, and RG58, 50 ohms, 10 base 2 thin Ethernet. And coming to the category RG15, the impedance or the potentiality, we can define it 75 ohms. Applications is meant for the cable TV. RG62, and here the category type is RG62. The potentiality or the impedance level is 93 ohms. And the type of application is ARCnet, attached resource network. These are the categories of the coaxial cables according to the RG ratings, like radio government ratings. So coming to the connectors which are used under, if you can use the coaxial cables, there are three type of connectors we have to identify here. The first one is the BNC connector, second one is the BNC terminator, the third one is the BNC-T. So the BNC-T is a connector which can able to connect between the BNC connector and BNC terminator. So the BNC connector is used to connect the end of the cable to a particular device, such as, if you can take the example of a TV set, the BNC connector is used to connect that particular type of device at the source end. And the BNC-T connector which will be present in the middle is used as a Ethernet works to branch out a connection to a computer from one device to another device. And the last one is the BNC connector is used at the end of the production of a one signal. So coming to the applications of a coaxial cable applications, these are widely used in analog telephone networks, where a single coaxial cable could able to correct or carry 10,000 voice signals at a time. Later, it was used in digital telephone networks, where a single coaxial cable could able to carry the digital data up to 600 Mbps. However, the coaxial cable in telephone networks has largely been replaced today with fiber optic cable. And the next application of a coaxial cable is nothing but that cable TV networks also use coaxial cables. In the traditional cable TV networks, the entire network used coaxial cable. Later, however, the cable TV providers replaced most of the media with fiber optic cable works nowadays. Hybrid networks used coaxial cable only at the network boundaries near the consumer premises. So coming to the third one of a guided media, what we can call it as a fiber optic cable. It is made up of a glass or plastic for the passing of or transmitting the signals from one transport media to the another transmission media in the form of a light. To understand the optical fiber, we first need to explore several aspects of the nature of light. The nature of light consisting the two types of properties. The first one is the reflection and the second one is the refraction. Coming to that, the reflection is a process in which the light will be coming back, or bouncing of the light we have to see within a fraction of seconds. So coming to that, the refraction process, when a light transmits from one media to the another media, or from one substance to the another substance, we can identify the bending of the light rays while it transmits from one media to the another media. This is the process of the refraction. We are coming to the reflection. The bouncing of the coming light, it will be coming back within a fraction of seconds when it travels or touches any substance, or it will travel through any type of one thing. So here, and the second point is nothing but light can able to travel in a straight line as long as it moving through a single uniform substance. If a ray of light traveling through one substance suddenly enters another substance, the difference density we need to identify there. The ray changes the direction, how it will changes the ray of direction by means of a bending of light rays through different directions. The first one, if you can identify, it is having one less than the critical angle refraction, having the less dense and more density. That means a light can travels or starts it traveling from one starting position. Initial level is the one, if you can assume, the one is less than critical angle refraction. It will be passed through a straight line. So coming to the second direction, if you can think it or assume, the one is equal to critical angle refraction. That means comparatively refraction is, as I have already defined, it is nothing but when a light travels from one media to the another media, the light rays can able to bend in one direction. Here we have to identify the slightly bending of the light rays. It transmits from one direction to the another direction. If you can comes into the second stage or the second diagram, here you can identify the light can travels from one media to the another media, having the less dense and the more dense also. So here it is having the light bending slightly. We have to identify. Compared to the first diagram, the second one is having more bending. And coming to the third one, the less dense and the more dense, one is greater than critical angle, what we can call it as a reflection. That means what I want to define means, what I want to explain means, here we have to see the two types of stages. The first stage is passed through the type of a refraction. The second type is passed through the type of a refraction. And finally it reaches the process of a reflection. That means a light can travels through the transmission media, can able to passes the two type of stages, what we can call the refraction. Finally, it will reaches the destination under the process of reflection. That means it will be coming, the light can able to get back within a fraction of seconds. And coming to this, the fiber optic cables, what we can call nowadays, these type of fibers are vigorously used. Optical fibers use reflection to guide light through a channel. A glass or a plastic core is surrounded by a cladding of less dense of plastic. So here if you can identify the figure, optical fibers, it will be consisting of having holding the one source or the sender and the receiver. When a light transmits from one direction to the another direction through by means of a core signal, here we have to identify the two type of claddings we have to observe. The first one is meant for the upper layer, second one is meant for the lower layer. So such a beam of light moving through the core is reflected off to the cladding instead of being refracted into the shown figure, the following figure according to 6.10. So coming to this is the type of showing the composition of a typical fiber optical labels. We should be having below the Kelver is a strong material used in the fabrication of bulletproof vests, and below the Kelver is another plastic coating to cushion the fiber. So the fiber is at the center of the cable and it consisting of cladding and the core, like the cladding and the core. The fiber is situated in between the middle, consisting of outer jacket, and one is the cladding initial level and second one is the plastic core. So the Kelver is for extra strength. This is the composition of a one optical fiber which can made it. So coming to that, there are three type of connectors for fiber optic cables as shown in figure 6.14. The first one is the SC, subscriber channel, and second one is the straight tip ST, third one is the MT, mechanical transfer resistor, and the first one SC connector is used as a for cable TV connections, and like it uses a push-pull locking system. And coming to the second one, the straight tip ST connector is used for connecting the cable for the sake of networking devices. So coming to the last one, the mechanical transfer resistor jack is a connector that is the same size of RJ 45. So here we have to identify the three types of connectors which are meant for the optical fiber cable. The first one is the SC connector, second one is the ST connector, third one is the MT-RJ connector. These are the type of connectors which are situated, which you have to see under the optical fiber cable. So coming to that, the unguided media, what we can call it as a purely wireless communication, and it transports electromagnetic waves without using a physical conductor. This type of communication is often referred as a wireless communication, and signals we have to see under the wireless communication. The type of signals are normally broadcasted through by means of a free space or air or by means of earth, and thus are available to anyone who has a device capable of receiving them. And under the figure 6.15 shows electromagnetic spectrum for wireless communication, which will be having radio waves and microwaves. The type is infrared. Capacity will be 300 GHz to 400 THz and 900 THz. The type is not by means of a light wave. So coming to that, unguided signals can able to transfer from the one source to the destination in several ways, either by means of a ground propagation, by means of a sky propagation, and by means of a site propagation. So coming to that, the three types of propagations under the unguided media, I want to discuss one by one. In grounded propagation, the radio waves travels through the lowest portion of the atmosphere, hugging the earth. So this type of low frequency signals connects in all directions or emanate or scattered in all directions from the transmitting antenna and follow the curvature of the planet. And the type of distances depends on the amount of power in the signal. The greater the power, the greater the distance. So coming to the second propagation is nothing but the sky propagation by means of air, consisting of high frequency radio waves which could be radiate upward in the ionosphere, the layer of the atmosphere where particles exit, what we can call it as the ions, where they are reflected back to earth. This type of transmission allows for greater distances with lower output power. The third one is under the unguided signals. The third one is the site propagation, and it is holding very high frequency signals which can able to transmit it in straight line directly from antenna to antenna. Antennas must be directional, facing each other, and either tall enough or close enough together. So coming to that unguided media, which we can call it as the definition of unguided media is nothing but the wireless communication. We can divide the wireless communication or unguided media into three broad groups. The first one is the radio waves, second one is the microwaves, third one is the infrared waves. So coming to that wireless transmission, the first one is the radio waves, and for the most part it should be the radio waves is always omnidirectional. When an antenna transmits radio waves, they are propagated in all directions. This means that the sending and receiving antennas do not have to be aligned. The omnidirectional property has a disadvantage also too sometimes, and here the radio waves transmitted by one antenna are susceptible to interference by another antenna. They may send signals using the same frequency or band. So coming to the next application of a radio waves, particularly those waves which can propagate in the sky mode only, can able to travel or transmits upon to the longer level of distances. This makes radio waves a good candidate for long distance broadcasting such as AM radio. And coming to that omnidirectional antennas, the omnidirectional antennas which sends out signals in all directions. Based on the wavelength, the strength, and the purpose of a transmission, we can have several types of antennas. According to the figure 6.17 shows how the omnidirectional antenna will be. So this is the type of omnidirectional antenna. Nowadays it will be used vigorously to the society. And applications of the omnidirectional characteristics means the omnidirectional characteristics radio waves make them useful for multicasting, in which there is one sender but holding many receivers. We have to identify here one type of sender will be there, but the receivers are many more. And here these are the type of examples which we can already discussing. The applications of the omnidirectional antenna is nothing but the AM, and nowadays the FM radio, television, maritime radio, cordless phones, and paging are the best and simple examples for the multicasting of a broadcasting technologies. So up to now, and I have discussed about the TCP IP protocol as well as the transmission media under the computer networks. Thank you one and all, and keep watching the computer networks for the upcoming video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.